Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zidan Aqila and I'm from Information System Department. Today, I would like to explain you all about my understanding of machine learning. Machine learning is a machine developed to be able to learn by itself without direction from its users. Machine learning is developed based on other disciplines such as statistics, mathematics, and data mining so that machine can learn by analyzing data without needing to be reprogrammed or ordered. In this case, machine learning has the ability to obtain existing data with its own commands. Machine learning can also study the existing data and the data it obtains so that it can perform certain tasks. The tasks that can be done by machine learning are also very diverse depending on what he learns. Machine learning models can be categorized as supervised and unsupervised learning. First is supervised learning. It involves a series of functions that maps an input to an output based on a series of example input-output pairs. For example, if we have a data here, that there are two variables, which is age as an input and shoe size as an output. We could implement a supervised learning models to predict the shoe size of person based on their age. Supervised learning can divide it into two categories, which is regression and classification. In the regression model, we find a target values based on independent predictors. That means you can use this to find relationships between a dependent variables and independent variables. In the regression model, the output is continuous. There are several types of regression. First is linear regression, which is simply finding a line that fits the data. Its extension include multiple linear regression, that is finding a plan of best fit, and polynomial regression, that is finding a curve for best fits. Second is decision tree. It looks something like this, where each square above is called a node, and the more nodes you have, the more accurate your decision tree will be in general. Third is random forest. These are ensemble learning techniques that builds off our decision trees and involve creating multiple decision trees using Bootstrap. The datasets of original data and randomly selecting a subset of variable at each step of the decision tree. The model then select the node of all the prediction of its decision trees and be relying on the majority wins model. It reduces the risk of error from individual tree. Fourth is the neural network. It is a multi-line model inspired by human mind, like the neuron in our brain. The circle is represent a node. The blue circle here, which is first layer, is an input layer, and the second entry layer is hidden layer, and the fourth layer is output layer. In the classification, the output is discrete. Some of the most common types of classification models include first logistic regression, which is similar to linear regression, but is used to model the probability of a finite number of outcomes, typically 2. The output values can only be between 0 and 1. Second is support vector machine. It is a supervised classification technique that carries an objective to find a hyperlane in n-dimensional space that distinctly classifies data points. Third is naive Bayes. It is classified, which acts as a probabilistic machine learning model used for classification tasks. The crux of the classifier is based on the Bayes theorem. Next is decision tree, random forest, and neural network. The second is about unsupervised learning. It is used to draw inferences of find patterns from input data without references to be labeled outcome. The main methods used in unsupervised learning include clustering and dimensionality reduction. Clustering involves a grouping of data points that frequently used for customer segmentation, fraud detection, and document classification. Common clustering techniques include k-means, hierarchical, mean shift, and density-based. For dimensional reduction, it is a process of reducing dimension of your feature set. It can be categorized as feature elimination and feature extraction. A popular method of dimensionality reduction is principal component analysis, or we call it PCA. It is the example of implementation machine learning in Coca-Cola Company for recognizing age of customer and the bottle. This is the speech recognition that used in Google Company. And for the virtual personal assistant, the example is Siri. So now I want to explain about how neural network works. Neural network are made up of layers of neurons. These neurons are the core processing units of the network. First, we have the input layer here, and then this is the hidden layer, and the last is the output layer to predict our final output. In between, so here is an image of a circle. This image is composed of 28 by 28 pixels, which make up for 784 pixels. Each pixel is fed as input to each neuron of the first layer. Neurons of one layer are connected to neurons of the next layer through channels here. Each of these channels is assigned a numerical value known as weight. The input are multiplied to the corresponding weights, and their sum is sent as input to the neurons in hidden layer. Each of these neurons is associated with a numerical value called the bias, which is then added to the input sum. The value is then passed through a threshold function called the activation function. The result of activation function determines if the particular neuron will get activated or not. An activated neuron transmits data to the neurons of the next layer over the channels. In the manner, the data is propagated through the network called forward propagation. In the output layer, the neuron with the highest value first and determines the output. The values are basically a probability. For example, here, our neuron associated with square has the highest probability. We know the neural network has made a wrong prediction, but does the work figure this out? Note that our network is yet to be trained. During the training process, along with the input, our network also adds the output fed to it. The predicted output is compared against the actual output to realize the error in prediction. The magnitude of the error indicates how wrong we are in the sign, suggests if our predicted values are higher or lower than expected. The arrows here give an indication of the direction and magnitude of change to reduce the error. So this information is then transferred backward through our network. We call it back propagation. Now, based on this information, the weights and are adjusted. This cycle of forward and back propagation is iteratively performed with multiple inputs. This process continues until our weights are assigned such that the network can predict the shapes correctly in the most of the cases. This brings our training to an end. I think that's all from me. Wassalamualaikum warahmatullahi wabarakatuh.